Okay, so in a related rates problem, you'll be given the rate of change of one quantity and then be asked to find the rate of a change of a related quantity. Okay, so for example, if you were pumping air into a balloon, then you can imagine, if I'm blowing up this balloon, that both the radius of the balloon and the volume are increasing, and that the way that they're increasing are actually related to each other. Okay, so the volume is growing at a rate, the radius is growing at a rate, and we can find a relationship between those two completely constantly changing values. Okay, so to solve these kinds of situations, you're going to need to find an equation that relates the two quantities. That's what we were doing with those similar triangles. We were trying to find relationships in between those quantities. Then we're going to use the chain rule to differentiate both sides of the equation, often with respect to time. Okay, so if I say I'm pumping air into a balloon and the volume is changing, then the volume is changing at a rate, and when I say rate, we're thinking of with respect to time. It's getting bigger at so many cubic centimeters per second. The radius is changing at so many centimeters per second. So the thing that relates the volume and the radius is going to be time. So they're both changing with respect to time. Okay, so let's have a look through this example. So air is pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. So a constant increase in the volume. How fast is the radius of the balloon increasing when the diameter is 50 centimeters, i.e. when the radius is 25 centimeters? Okay, so imagine a balloon being pumped up. If you're increasing the volume at a constant rate, is the radius increasing at a constant rate? So if you have a little balloon and you put 100 cubic centimeters into it, you say the radius got big pretty quickly? If you got a really, really big balloon and you put 100 cubic centimeters into it, can you see that the radius got just a little bit bigger? So the bigger the balloon is, the speed of the radius increasing is slowing down. Can we see that? So while the volume is growing at a constant rate, the radius is not growing at a constant rate. So when I say how fast is the radius increasing, I'm looking here for an instantaneous rate of change because it's not going to always be the same. Okay, so here is let's always start with the key if we're going to introduce variables, and I'm just going to let V equal the volume and R be the radius for our balloon. Okay, do you know a formula that relates the volume of a sphere to its radius? Well, of course you do. Volume is equal to 4/3 pi r cubed. Okay, just the formula for finding the volume of a sphere. Okay, so once you can find a relationship between your two variables, then you can differentiate both sides of your equation with respect to time, because time is the element that is consistent with both of those. They're both changing with respect to time. Okay, so I'm going to take the derivative. So if this is our equation relating volume to radius, so this is just the volume of a sphere. Then if I start here, I'm just going to rewrite it. Volume equals 4/3 pi r cubed. Then as long as I do the same thing to both sides of the equation, they're both equal. Well, this is what I'm going to do to both sides of the equation. I'm going to take the derivative with respect to time. if you go back and read through your equation, then it says air is being pumped in a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. So this is what is given to me in the problem. The change in volume with respect to time is equal to 100 centimeters cubed per second. Say that again. We said the volume increases at this rate. Well, that is telling you what the change in volume is with respect to time. Do you see that? You've got volume over time. Your units really help you in these kinds of problems. Okay, what's the question you're being asked? How fast is the radius increasing? You're looking for the change in the radius with respect to time. That's the question you're being asked. And as we just discussed, that's not constant like our volume is. We're being asked to find that at the instant R is 25. Okay. So there's the setup for it. And let's go back to this relationship between volume and radius. Derivative of v with respect to t, can you see I could just do a substitution for that? What about this? I'm taking the derivative of 4/3 pi r cubed with respect to time. How do you do that? How do you take the derivative of a variable with respect to a different variable? It's one word. Implicit. It's an implicit differentiation. So we get this dv by dt, and we're just going to leave it symbolically like that because we already know we've got a substitution for it, is equal to, so implicit differentiation, let's simplify this. Do you see that 4 pi over 3 is a constant? Pull it out in front so we don't complicate this. So 4 pi over 3, there's our constant, and I still need to take the derivative of r cubed with respect to time. How do I take the derivative of r with respect to time? Implicitly, then, I've got dv by dt is equal to 4 pi over 3, and the derivative of r, 3r squared, dr by dt. Implicit differentiation, or 3r squared r prime. Questions about that? Key concept. Okay, from here it's algebra. We're just going to simplify this. So you can see the 3's cancel. I get dv by dt is equal to 4 pi r squared dr by dt. Well, that's great because I've been given dv by dt and I'm trying to find dr by dt at this moment in time. So then I've got, let's just take this and rewrite it. So dv by dt, now I'm ready to substitute. So this is 100 centimeters cubed per second is equal to 4 pi times 25 centimeters all squared dr by dt. And 4 pi times 25 squared, so I've got 100 divided by 4 pi times 25 squared, and this was centimeters cubed over centimeters, which are going to be squared, is going to leave me with centimeters per second. Can we see that? Our units will cancel. We'll be left with centimeters per second is equal to dr by dt. So just simplifying that, 1 over 25 pi will give me dr by dt. Or if you want it in decimals, thank you. Okay, so what's the rate of change of the radius with respect to time is 1 over 25 centimeters per second when the radius is 25.